I start? Yeah? Sure? Okay. So, thank you for coming. I'm very pleased to give this talk here. So, my name is written, well, this is not me. Huh? This is Isaac Newton. And this guy is Steve Jobs. My name is there. So, I am Joël Chevrier. I am a physics professor at university in France. And I'm very much interested in using smartphone to enter science and especially physics. Because first time I received a smartphone, I thought it was designed for people like me and to do experimental physics. It sounds as it's not the case, yeah? Smartphone has not been done only for people like me, yeah? And one thing I do with my students is this. I really do it this way. We do the pendulum experiment just like that. And the pendulum experiment, I like it very much for two reasons. Pendulum has been the way to measure time, clock, for ages. Yeah? Until the middle, I think, of the 20th century, it was the best way using a pendulum to make a clock. Well, nowadays you have the atomic clock and then you do much better. But before, I think pendulum were really good. And the other point is that, I don't know, if you have a huge pendulum, that in French we call pendulum of Foucault, then you can probe the fact that the Earth is rotating using a pendulum. So it means that the pendulum is an extremely important experiment. And as soon as I realized what's inside the smartphone, then I knew that I could do this experiment and get the data from my smartphone and do a quantitative analysis as a physicist of what the pendulum is doing. When I mean quantitative pendulum analysis, I can measure the angle. I can measure the speed versus the time. I can measure the acceleration. I can measure the acceleration in this direction. And I can measure the acceleration in this direction. I can measure the acceleration in this direction, and if I do the things well, I'm not going to find any acceleration because it's moving only in this direction. And I can do that in real time. And this is what I do. We do it in real time, and this is essentially what I'm just going to describe you is that me, as a professor of physics, professor of science, I consider my smartphone, well, not always. Maybe I use it like everybody, yeah. But many times, I use it as a lab. And this is the reason why here we call it a pocket lab. Yeah? And we'll come back together of what's inside this. And when I was at your age, having the opportunity to do science with the lab that is a smartphone was just impossible. It would have been necessary to spend millions of dollars when I was your age to have the experimental facilities that are equivalent nowadays to a smartphone. And then I find it great because now I can do physics and science with it. And this is what I'm going to explain. So this is the reason why I say that here, this is my pendulum, and this is joining together Isaac Newton, pendulum, mechanics, movement, trajectory. The way we describe it is really very much originates into the work of Newton law. And Steve Jobs for the smartphone and all the sensors, transfer of data. Okay? So I wrote that for the Facebook and Twitter, but now I know how to use WeChat. So if you're interested, you can even ask me to come and to be linked through WeChat. Yeah. So the people I've been working with, in order to do that, you need two kinds of people. Well, you have the smartphone, so you don't have to build the smartphone. That's a good point, yeah. But you need two kinds of people. You need a scientist, a physicist, at least one. Here we have two. Ahmad Biessi, my colleague, professor of physics in my university, and myself, we are the physicists. Laia Madani, guess. You might guess what she's doing in life as a job. Computer science. You need somebody from computer science to do that. Why are we so keen of that? Why do we like using smartphone to do science, to do physics, experimental physics, to do measurement? Because it's extremely efficient to do that. They're extremely good at doing that. And also the thing is that if we say that we're working together using the smartphone and doing physics, yeah? Do I need to come with the smartphone from my country and give you that? You say, no, I have my own here. Probably most of them you do have a smartphone, yeah? I don't know, yeah? So it means that on Earth now, you have more than 2 billion of smartphones. So you don't have to equip people. They're equipped. It's done already. They all have their pocket lab. You do have a pocket lab in your pocket, yeah? And you can do all things I'm talking about, you can do it. The software I'll be talking about is online. So you can just download it on your laptop if you have access to a laptop. You have a smartphone, you have a laptop, you do everything I described. It's open and free. Here is we call frugal science. Frugal science means this. I put it in euro, but since this is €0, it's most probably zero in any kind of currency, yeah? Yeah? So you need a smartphone. Well, it's desirable to have a screen connected to a laptop. Nothing added. I mean, no lab. You don't need a lab. Usually when you do experimental science, you go to a lab. Yeah? Here, you stay home. Or you go out. Or you go anywhere you want. I don't care. As long as you have your smartphone and a laptop and ideas. Here you have ideas and things around you. For example, for the pendulum, you say, okay, I have the smartphone. How can I do a pendulum with that? Okay, look at that. Well, it's no problem. You take this and you say, okay, now it's ready. I have a pendulum. Yeah? What's the price to build up the pendulum? €0. It's done. And for all experiment I'm going to talk about, the thing is that you want to do it, no money. Just the laptop and the smartphone. And the rest of it, ideas that you look around you in your kitchen, for example. So, the keywords are, bring your own device. That's the one you have. Do it yourself. Have ideas and find things around you. And then we built up this massive open course online so that you get the method. You get the kind of experiment we've been thinking about. Then if you come to this, which is online and open also, you can just register now. If you come and register on Smartphone Pocket Lab, you find that, you register, and then you do it. And it also means that we start to build up communities of students and teachers so that you can do experiment together. That's what we're aiming at. So it's only the beginning. So for the MOOC this year, we had 1,000 people registered, participants. It's good. We liked it. 1,000 people where we were thinking about. Future, we'll do better. Okay, once again. Using the smartphone to do experiment is something like a challenge for professors. You find it at very first, you say, okay, people with the smartphone, they've been extremely good. Because they built up this machine, and this machine is used by you, by my mother. She's 80, and she has a smartphone, and she's really using it very nicely, yeah? My son, well, my son is your age, so it's okay. I mean, he knows how to do that. But kids, what's the youngest kid you know is using a smartphone? Think about that, yeah? It means that it's valid for everybody, everywhere, any age, any culture, any background, doesn't matter. That's my first time in China. I'm very pleased. First time in Shenzhen. Great. Really, I enjoyed very much. I spent 10 days here. That was really great. So we don't know each other. You don't know, probably you know a bit of my culture, maybe France, you heard about. Same thing for me in China. When we speak about smartphone, we immediately know what we're talking about. We never met each other. Your story and my story are disconnected by 10,000 kilometers. When we speak about smartphone, immediately we know what it is. So when I use it for experimental science, I should be able, well, that's difficult. If I can provide experimental science for everybody, everywhere, any age, any culture, any background, then that'll be really great. But these guys with the smartphone, they've been doing really good. Okay. What's the reason why I can do that? A bit more into details. Sorry. Why is that? Well, that's funny, huh? I never thought about that before. I mean, why is that in most of the smartphone where you don't find everything, but most of the time you find a gyro. So there's a gyro is there to measure this. Orientation, angles, the way you're moving it like this. Yeah? Accelerometer is there to measure this. No velocity. No velocity. Well, between the two, I moved. So there was a velocity, yeah? I displaced. So this guy here is able to measure that like this, and like this, 3D. Well, there is a magnetometer. It's measuring the Earth's magnetic field. The Earth is a little magnet, yeah? And it has a field that has kind of a direction. That guy is measuring that. As long as you're using your smartphone, it is measuring the Earth's magnetic field all the time. It's money, you know. When you put that into a smartphone, you must decide that you put these things in. Yeah? You have to do it. The recent one, they're even measuring the pressure and the temperature. And of course, there is a microphone because you speak to people with. You hear a kind of a loudspeaker. You've got 2 cameras plus a light, and you have Wi-Fi, Bluetooth, and NFC communication. I told you this is a lab, yeah? The reason why you have all this here, why do you have all this? It's essentially so that the image is always in the right direction, yeah, the way you want. When you do this, it's just rotated. That's the reason why they put that in, only that. So it means that these advanced sensors, they're here to fit the way you move. Yeah? And they're sensitive and they're quick enough so that they're just following you. That's the reason why they're there. And that's great. And of course, that you know, it collects data, it reads the data, it represents the data, it sends the data to where you want. So, kind of a summary. When Steve Jobs presented in June 2010 the introduction here of the gyro, they added to the accelerometer. He went for a keynote and said, look, we put a gyro in that. And he put a gyro and the conclusion of his presentation, so that he said, here you have the gyro, you have the accelerometer, and then you have core motion API, and the conclusion here, well, you cannot read it, so I'm just going to tell you. The conclusion of Steve Jobs is that, you imagine this? It's perfect for gaming. The smartphone is just perfect for gaming. And me, as a scientist, what I'm adding is, I just wait for the picture. Our project, for people like you, is to say, gaming might be learning science. And we would like to try so that when you use what you're doing, you find it fun. That you're gaming and at the same time you're learning science. And this is one of my students. I told you, he's studying the pendulum. And at the same time, on the screen behind, there is all the data represented real time. So that if he does this, there will be big energy. If he does this, that's a very small energy. If he does this, the angle does like this. If he does like this is only a small oscillation. It can measure the periodicity versus the length of the cable, all this. Okay? In real time, just because real time is nice. I mean, if you have to look after, it's not gaming. So you do it at the same time. So, but, I'm just going to explain this. These things, sensors, data treatment. Data treatment is that's mean inside here is essentially the bachelor level at university. You need science taught at the bachelor level at university so that you can treat the data coming with the sensors. Yeah? And after that, you've got the designer. They take this treatment and they make a user interface so that the sensors and the science that work in that, you don't care. I mean, you're using a smartphone and you're never thinking, The sensors are capturing data during the time I move, and then there is a scientific treatment in line, and that's treated, and then it comes out, and I have a user interface, and then I can move it nicely. You just move it nicely. That's it. You don't care what's going on after. So what I do now, I'm a physicist. Physicists, they do model. They try to explain and to understand. Yeah? So they simplify the situation. So this is my smartphone. I don't know if you recognize your smartphone there. Probably not, because there are a lot of things missing, but I don't care. Data through the sensors. I measure the angle. They're coming here. They measure acceleration. That's all coming here. Here I do this real-time scientific treatment, equation calculation, numerical calculation, blah, 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 blah. Then it goes through the user interface, and here is the user, and then what happened here is that you did this. When you did this, the gyro and accelerometer calculated all the angles and acceleration and everything. They say, oh, it turned the smartphone, guys. So, woof, it just rotated the picture, the image. And here, you see that the image is rotated. All this has been done through. Okay? What we do now here for our experiment first is that we take the data here. So, no user interface work here. But now, this is good for university level here. These data are not easy to treat. They're difficult. The pendulum experiment might be somewhat difficult. And now the kind of things we're working on is how can we define a user interface so that I do respect what I said. Steve Jobs said, the smartphone is perfect for gaming. They say, well, this is no gaming. Yeah? What you explained there, it starts to be a bit tricky. So now what I would like to do, instead of having the classical user interface that we're all using, I would like to define a new one, a scientific one, especially for you, so that when you take it, you say, oh, now I'm gaming. Now I play with the science, yeah? And it's not done already, so maybe I come back next year. I'll provide you with the new user interface so that you can play science using your smartphone. Not already done. That's what we're working on, and that's kind of collaboration we're building up with people in Shenzhen so that maybe we can try to think and enter this. So we build up this program, this software. This is the name of our software. So the software is just receiving the data on the laptop, treat the data, and represent them with scientific description. Well, this is no fun. This is no fun. I show you what it is. This is it. This is the pendulum experiment once again, yeah? It's probably, I'll probably break my smartphone by the end of this presentation. What do you think, yeah? So I do this. I do this, like this. Okay? It's oscillating. And at the same time, I see the representation of the smartphone doing this. That's the angle. Well, I don't see it because this is not a video, yeah? This is a capture. But if it was a video, it would do this. And this is now here the video. This is a movie of the smartphone oscillating. Here is the energy. So if you move it like this, then the green curve here will be here. If you do very little oscillation, very small, then the green curve will be there. Small oscillation, small energy for the movement. If you move it with large oscillation, high energy for the movement. Okay? This oscillation here means that when it is here, no speed, no energy associated to displacement and velocity. When it is here, it has a very high speed, but it's not going to go down further. Yeah? So it means that this is kind of oscillation due to the energy associated to the height, and another one that is associated to the velocity. My students are working with that. And here, this is representation for the velocity and acceleration, all needed at university. Typically, that is used at university. So for other people, as I told, we need now to take this. And so next time I come, I propose you another talk and maybe an app. And then you say, well, that I don't understand it. But the new one, I start to understand. And maybe the year after, you make it better even. Yeah, that's what we're in. So the purpose here is to say, I pick up the data here when I do this pendulum experiment and when I rotate it, and I propose you a way so that you learn something about movement and you understand it, which is probably not the case at the moment. And I'm sorry about that. Another thing is that what we did with my students, you forget about everything except the fact that this is my town here. So this is a tramway, a train. You put the smartphone in it. You start collecting the data. And it's good enough with the smartphone so that you can, from the desk measurement, you calculate here the trajectory of this guy. And you put that onto the picture of the town, and it fits. This is what I do with my students. Yes, it is great. Thank you. Now, it's really great. It's amazingly good. Oh, that maybe you do not. I don't know if you have that in this country. In France, we do that a lot, but maybe you know, when you want to have a dry salad, how do you do it here? You have things to rotate and that you have the water coming out, yeah? So instead of putting the salad, you put the smartphone. Yeah, and you do rotation. And then during the time you have rotation, you look at the screen on the laptop and you see the energy. And if you rotate very nicely in a constant way, then the energy associated to rotation is just constant. If you do it in a bad way, so that ooh, ooh, like this, then the energy does blue, blue, like this, yeah? So that's also things I do with my students. I told you, €0 to do this, yeah? So the salad spinner, usually you don't buy it specifically. Well, you clean it a little bit after, otherwise the salad might, depending on what you, that's okay. If you don't have a salad spinner, well, that's okay. If you don't have a salad spinner, you take the smartphone and you say, okay, I want to study rotation. Well, okay, that's a rotation. I do that. You do it by hand. Why not? When you're interested in probing fundamentals of movement, you say, okay, I'm interested in this. Maybe I go to an elevator. If you have an elevator, you put the smartphone inside the elevator. Start with the elevator. So you start, displacement, you stop. Then you study only displacement. But sometimes you don't have an elevator, depends where you are, yeah? Okay, so if you don't have an elevator, you do this. It's just the same displacement, yeah? Why not? Rotation, you do it by hand like this. Yeah? Or like this. They're very different. That's equivalent to the moon rotation. That is not equivalent to the moon rotation. So you start to study questions like that, yeah? And you study it very nicely. These are the data. Maybe I'm checking a little bit, yeah? Well, that's a circle that's only approximate, yeah? It's supposed to be a circle. Well, it's okay as a circle. The circle you can calculate in theory would be like this. So, not too bad. This is in the space, technical aspect is that this is in space of acceleration. But that's it. So at the end, just to finish with this, here, what we did is that we organized the massive open online course in 5 sessions. First session is this. Second session is this. Third session is pendulum. Fourth session, people like me, we like vibration and oscillation. Yeah, very much. This. Or you put it here on the table, you do this, and you're measuring the vibration of the table. It does this. You can really study, I mean, that's earth at the end, yeah. You can really study the vibration of the table. You do that, and it works nicely. And the last one, which is the one people are working on at the moment in this MOOC, your own idea. So you might use your bicycle, you might run, you might put it in the train, in the plane, any kind of real trajectory you would like to study. And you're going to study it. I did the tramway and the plane and the train and the metro. What did I do? No, I didn't try skiing. I didn't try skateboard. I didn't try running. Well, running has been done by so many people. So there are any other ideas? So that's just a kind of advertisement. It means that in France, this is the major newspaper, and they were very nice with us, and they wrote a paper about the way of using smartphone to teach science. And the other one is also a French newspaper about education. Okay, so just to first speak about what we did, and I'm just going to use my smartphone to know what time is it. That's another way to use it, yeah? So I started something like 40 minutes ago. No, half an hour ago. A bit more. No less. Not tired? It's okay, I carry on. Questions maybe for this part? Because I'm just going to change a bit. We'll see after. Keep the question for after, if you have question. I had a point now. I had a point is that who is at university? Here? Nobody. Who is at high school? Okay. Probably what I presented, you're not going to use that at high school. Am I correct? I get the feelings that, or middle school, let's say, for middle school, what I presented is too difficult.
It's okay. Like we've done some research on this, and we've seen that there are some experiments based on AP physics.
Yeah.
And we are currently learning AP physics.
Okay. So, what do you to what level do you think what I presented could be used? Down to, if you're for people 8 years old, 10 years old, 12 years old, 15 years old?
Well, like senior one, like 15.
Okay.
Or even 14, like in the junior high.
So now below. Below, no. And then I have to think about something different, because you might be interested, even for younger students or for non-scientists, people doing something different, to study movement and how movement can be shown and explored and can be used, but not with this, because probably for most people this is too much advanced. Yeah? Not all people are coming to what I presented. You need to do real science to enter that, yeah? And that's what you're doing. So the idea now is to say, how can I define something that can be used by anybody? And still looking at this, maybe, or other things, moving, trying to do this, for example. That's also movement, yeah? It's a kind of a pendulum. So we have now we are now coming into a project that's called the Magic Wand Project. Magic Wand means that I do this to you with my smartphone. What's happening? That's exactly what we're talking about now. Or I want to send you a message. Maybe if I want to send you a message on your phone, so WeChat, I do chuck, and then the message will come. Why not? Yeah? So that's what we're entering in. And well, it's written small, but the Magic Wand does movement in real world. Yeah, if you have a magic wand, then you do something like that. You do magic, but you're moving in real world. But your smartphone is acting and sending messages, information, data into virtual world. Yeah? And so the dialogue between the virtual world and your own movement is the question. One thing we decided when we entered the magic wand is that we're not going to use the screen of the smartphone. Well, you're using the screen most of the time, yeah? You're always like this, yeah? You notice that? Here, what we want to do is that, no, you're going to use it this way, moving. No screen. Yeah, you're not going to use the screen. Not this screen, maybe another one, or maybe you'll send the data on the screen of a friend, but not your screen. Not this one, at least. And we do that on purpose, because we want to focus on movement. So these real moves now connect then to the virtual world. They can transfer real time or not, the data and information to people, objects, networks, and they have this movement, very far maybe, they have real consequences. They transform information, for example. And we believe this is where the magic is. So the magic one can be two things. Or it can be a smartphone, where you're using the sensors inside without the screen. Or it can be another magic one. You take the sensors out of the smartphone. Well, you buy them. You're not going to kill the smartphone for that, yeah? And you put that into a real stick, and then I start to do this. Why not? You put the gyro, the accelerometer, the Wi-Fi, the battery, and everything inside that. And then you have something that is equivalent for this of a smartphone without the screen. That's what we're working on. Exactly this. What do you do with this? Well, we decided to focus on two things. Writing means that, that I have problem now here because I don't know, we'll see. If I do this, in my language, this is a letter. Yeah? This is the first one.
Okay.
Yeah. I do it again.
Okay.
But that I can record. That I can record with this. This is one here, like this, yeah? Can I decipher that? Can I identify a A? Well, these are the data. That's supposed to be this. But in acceleration, in the way I'm changing, I'm doing the rotation and the displacement. So if I do this, or if I do, it's not going to be the same thing here. Same letter, but it's not the same movement. And this signal here is going to say, no, it's not the same thing. Well, don't try to imagine what this is, yeah? It's a nice one, isn't it? In a different space, this is an E, the first letter of the alphabet for us. Well, okay. You can even plot it in a different way, and this is one letter, another letter, another letter, another one, another one. This is the way I'm writing when you plot the data this way. Well, I write nicely, I believe. Okay, so what do we do with this? It means that you can start to write here C-H-A-T, which means in my language cat. Chat. Chat in French, that's a cat. And then you can, if I do that, on the screen of my friend, there might be, if I decide something like that, or like this, or like this, or like this. So I can send message, maybe, just by doing it in space. Why do we want to do that? Well, for you, maybe it's not useful, because you know to write, you hold, yeah? But we may even come to people, either very young, or with disability, or with problem to move, or that sort of things, and provide them an ability to say, move the way you want, the way you can. And we try to extract the information from your own movement. And we try to have the information out of that. So of course, you could do that with this. But then in that case, you're going really to move. You're going to enjoy the fact that you're not only doing that, but you can start to move really. So that's the kind of things we're thinking about. And also it means that when you do that, you might say, I'm not a musician, but I would like to play music. Maybe that helps me to do it. I can just use this movement to do one. Why not? And we have collaboration with people in Paris that are really musicians and interested in that sort of thing. So we're working on that. Okay, another thing is that, for example, one of you is coming here, and we're moving together, and we do this together. So you see, I'm doing it, and there is another me, and at the same time, so we both do this, yeah? Are you able to add movement? In physics or science you've done, how can you add the movement? You know how to do that? You take one movement, you take another one, and you sum them. Well, in real space, you say, well, this is two movements, and that's what it is. And that's it. There's no way to sum them and to have a representation of what the sum of these two, yeah? Well, if you do that in maths and numerically, why not? You sum them, and then you present them as a result of something that's added. And adding movement is moving together. Representation of the screen of moving together, yeah? Here, you have what I did. Here, you record that, you do another one. And here on the screen, you say, I put them together. Is that of interest? Well, that's the kind of things we're looking at now. I put that because this is in Africa, and these guys they have, a piece of metal that's very hot, and they want to transform it, so you do with a hammer. And with the hammer, you say boom, like this, so that you make it flat. So this one is just holding the things, and the three other people here are just moving together. Well, you have to do it very carefully, yeah? Otherwise, one of them will be really hurt, yeah, because this is boom, like this, yeah? This is kind of combination of movement. So if you equip them with smartphone, you might even see how good they are in combination very precisely. That's the kind of things, yeah? So here, they're just moving like this. So if you have, think about it, if you make the sum of the movement like this, then the result is a line like this. Because in this direction, they just sum to 0. Now if they're moving like this, then this is 2 circles, and you're just adding 2 circles in a coherent way, the result is a circle. This is it, here. So you can start to play with that sort of things. And that's really adding movement and considering. There is a maths concept. Yeah? You study this kind of things in maths. And I don't know if you came to that. It's called, the concept behind is called the center of mass. No? Well, you'll see it. And you might even have a look on this is combination of movement, yeah? So, well, but if they're really moving together, depending on the way they move, what about the point here, the middle? What is the middle of the two doing? If there is a smartphone on his here and there, what's the point in the middle? The point in the middle is the average displacement of the two. That you can have a look on with your smartphone. You can have a look on this displacement, on the point in the middle, or you can have a look from the outside. Why not? And that's what we're looking for. So if you put a magic wand on all these guys, then there will be something like that, yeah? And you do the combination of many people, and you can put that on a screen and make another representation on the way they're dancing together. But you need to, each of them must have a magic wand and play with that. Okay, finished. So people are very inspiring for us now. These are here, people really playing with smartphone, sensor, and magic. Really. So they're playing with the interplay between the real world and the virtual world so that you go to maybe a circus and you see what they're doing and you say, well, that's great. Yeah. These guys here at the Centre Pompidou in Paris, they're just working, they're essentially working, this is nice people working on smartphone, computers, music. So for the last part I described, it's very much interesting for us to collaborate with them. These are designers. One school in France of design, another one in Les Ateliers. And we need very much designers so that what we make at the end, you find it interesting. This guy here, this is a small company that's called Guken in France, and is interested in this, boxing. How you learn boxing. You put kind of a sensor on your hand here, or the magic wand, and you do this. What's the best move? And it comes also to science. Boxing comes to science, yeah? Because, well, obviously I'm not a boxer, yeah? But then, if you just do that, it's not going to be efficient, no energy. So what I got from this guy is that if you want to have energy when you're moving, you really have to move your shoulder and to have all your body putting energy in the way you're doing that, yeah? And it's very tricky movement to learn. So one way of using what I described is that your computer is going to record with the coach the best way to move. You can do boxing or other things. Yeah, you do boxing because they like that, but otherwise you can do other things. And when you're at home and you want to practice your favorite way of moving on sports or whatever, then the computer is going to help you as a coach. And this is very much an application of the kind of things we're looking at. But you need to be good at computer science in order to do that because the machine has to learn the way you move. Yeah? And as soon as you say the machine has to learn the way you move, then in terms of computer science, this is advanced level. And the last one here, Little Earth movement, means that people have been interested in describing movement a long time ago. And Anne Dubos, she's behind this Little Heart movement, and she spent 4 years in India looking at the way people are doing theater in a part of India, and they have a sign language and movement coded that are extremely important. And for the kind of things we're looking at for the Magic Wand project, having discussion with her is very important. And that's it. Thank you very much. So if you have a discussion or questions, you're welcome.